Sixth grade, lesson 13.6 is applying measures of center and variability. So we're still practicing those things we just went over in the previous lesson. This gives us a little more time for our brains to digest all of that information so we get some practice problems with it. Remember measures of center. What is kind of that middle, most center information of all the data? We could find that by doing the mean. That was the average, where you add all of the pieces of data together and divide by how many pieces of data there are. You can do that by finding the median, ordering all of the data pieces from least to greatest and finding the one that is right in the middle. Or you can find the mode, the one that is most repeated. And what we learned in the last lesson is the average can generally give us a pretty good idea of the measure of center, unless there's this major outlier on one end or the other, a number that is way off of the data set. And if that happens, then it really skews that mean in a different direction. So when that happened, we learned maybe use the median instead when that happens to find the measure of center. Mode was useful in that circumstance that we had a lot on one end of the number line and a lot on the other end of the number line. And we can say, well, that measure of center is not so much center, it's just that we have this split information and it tells us so by saying this is kind of the split of information. It's on extreme ends. So those were what we learned in the last lesson as far as depends on the scenario, which is better to use. It depends on the scenario. Mean is a good one to use, and unless there's a big outlier in there, then median might be better. Or if you have this big split where you have a mode on opposite sides of the spectrum, then that might be a good way to express the center of the information. Measures of variability, how spread out was the data? You can do the range, which was the largest number in the data set minus the smallest number in the data set. Or if you want to find it may be a little more accurate to where the bunch of data is and what the range of the main data is, you can use the interquartile range, the IQR, and that's taking that upper quartile, the median of the upper half, and then subtracting from it the lower quartile, which is simply the median of the lower half, and that'll tell you the range or the spread of the main data. So those are things we've been working on, and here we get to put them into action. All right, we have Julia collecting data on her favorite sports teams for a report. The table shows the median and interquartile range of the heights of the players on her favorite baseball and basketball teams. How do the heights of the two teams compare? So we're going to compare the medians of the baseball team and the basketball team to each other to find that center, to compare their center, their measure of center. And we're going to compare their interquartile ranges to compare their variability, their spread. So let's look at the median of and they gave us the median. They already ordered the information from least to greatest, and then they worked their way into the very center. And the median of the baseball team's height was 70 inches. And the median of the basketball team's height was 78 inches. So basketball players' center, the measure of center is about 8 inches more so than the median on the baseball team. So that's the greater than one. So we're going to put the basketball player's height is 8 inches greater than the median of the baseball player's heights. And I got that by doing 78 minus 70. The difference between them was 8 greater than. Let's look at their interquartile ranges now. They say the interquartile range of the baseball team is what compared to the interquartile range of the basketball team. So the interquartile range, the range of most of their heights ranged from within 6 inches of each other, and in the basketball team they were within 4 inches of each other. So the more spread out it is, the more variability it is, the more their range is going to be. So the interquartile range of the baseball team is more varied than the interquartile range of the basketball team, or larger, we could say. I guess I'm not sure what word they want there. It's larger. It's 6 as opposed to 4. And so the heights of the baseball players vary more than the heights of the basketball team. They have more variety of heights. Basketball team is taller, but they're all around the same height as each other. So the players on the basketball team are typically taller than the players on the baseball team. And the heights of the blank team vary more than, means that they have some that are shorter, some that are taller. The one that varies more, that has a variety, is the baseball team. So the heights of the baseball team vary more than those of the basketball team. So this is all just about comparing the information and what that information means. It's helping your brain digest it. What does the information mean? All right, and then we have Julia randomly picks a player from the basketball team and one player from the baseball team. Given the data that we were given here, can you say that the basketball player will definitely be taller than the baseball player? Let's explain our reasoning. Okay, let's reason this out. If my baseball team has a median of 7 and the interquartile range varies from the upper quartile to the lower quartile of 6, then I could say it goes 3 this way if this median is my measure of center accurate, and 3 this way. So this one would be 73 inches, and this one would be 67 inches, and that would be my interquartile range. If I chose a basketball player, their median is 78 inches with a 4-inch range. So from center, we'd go 2 that way to make it 80 inches, and 2 that way to make it him 76 inches. And that's not even lined up properly. I should line that up better. Let me line that up better. Okay, there they are lined up better. The same thing we were talking about. The median for the baseball team was 70. The range was 6, so I went 3 this way and 3 that way to get my box. You can see that this varies more than the basketball team. The basketball team had a median of 78, so I put that there. With a variation in the interquartile range of 4, that would put me 2 out this way and 2 out that way for a total of the interquartile range of 4. And so you can see these don't overlap at all. So at first I want to say, they are not going to definitely, can you say that the basketball player will definitely be taller than the baseball player? Yeah, when I look at it this way, I can say absolutely, definitely, yes. But what I also need to keep in mind is that, remember, we have those whiskers. So there might have been one guy who was here, or girl, I don't know if it's boys or girls or a mixture of both. And maybe on the basketball team there was one person that was here. So those whiskers may throw it off. So I can't I don't have enough data to definitely, for sure, absolutely sure say. But it's pretty likely that the basketball player will be taller than the baseball player. So I'll word that somehow. I would say something like the maybe wouldn't be definitely taller than, but very likely that the basketball player would be taller than the baseball player. Okay, and let's look at another example that we have here. We have Kamira and Joey who sold t-shirts during lunch to raise money for a charity. The table shows the number of t-shirts each student sold each day for 2 weeks. Kamira sold those, and Joey sold those. Find the mean and range of each data set, and use these measures to compare the data to each other. So we're going to find the mean and the range. The mean is a measure of center, just like a median is as well, and mode is the most repeated as well. Those are measures of center. And the range is going to be the measure of variability. How far does that information stretch out? So we'll compare those to each other. To find the mean, they help kind of guide us through that. We're going to take all of Kamira's data and we're going to add it all together. And when I add those all together, I get 30. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So I divide that 30 by 10, and 30 divided by 10 is 3. So the mean of Kamira's is 3. So on average, she's selling 3 shirts each day. I'm going to go ahead to do the median also, just for the practice for you to see that data as well. I'm going to put this down as a dot plot. Let me write the number line. Okay, so I have dot plotted Kamira's t-shirt sales in, and I'm just going to work my way into center, because when I put it in the dot plot, it puts me in least to greatest order, so that just makes it easy for me. Now I'm going to just kind of eliminate lowest, highest, lowest, highest, lowest, highest, lowest, highest, and that puts me at 3. So I have a median of 3 as well, so I'm just going to put that there. It doesn't ask for that. Mean is probably, for this data set, fine to use. Notice I have mode and mode over here, that split thing. That could have been good for a center of measure, measure of center as well. They asked for mean, so we went with it, but I just want to give your brain the practice and the comparison of the different ones. No ridiculous outlier on these, so nothing skewed. So mean is a good measure of center for this one. Let's look at Joey's. We're going to add all of Joey's up. He has a 0, 1, 2, 13, 2, 1, 3, 4, 4, and 0. We'll add all of those up and divide by 10. Okay, and I add them all up, and look at that, they end up being 30 as well, even though he has this crazy outlier of 13, but he has these 2 zeros as well. 30 divided by 10 is 3. So our means ended up the same. So on average, not considering that outlier, well, on average, considering that outlier, I should say, he's selling about 3 a day. Remember, when that outlier is there, it might be better to find out what his measure of center is with the median. Look at his dot plot with that outlier way out there. But as it turns out, in this circumstance, which is kind of strange, lowest, and if I do median, I cross off lowest, highest, lowest, highest, lowest, highest, lowest, highest, and here I end up with 2 as the median. So those medians ended up somewhat close anyway, but this is a little more accurate. But anyways, in the mean, we get 3. The median we'll put over here is 2. So I just wanted you to see that with that skew in there, what that does. But we're comparing the means, and their means end up about the same. So they sold on average 3 a day. How much variability did they have? Find the range of the data set. Well, we're going to take Kamira's highest one, which was 5, and subtract from it the lowest sales day of 1. And so her range was 4. So she sells from anywhere from 1 to 4 each of the days, with an average being 3. Joey's highest one is this 13 over here. And we subtract from it his lowest, which was 0. So he has a range. He can sell anywhere from 0 one day, a couple days, all the way up to 13. So that 13 really helped make up for selling no t-shirts for 2 days on that one. So his variability is higher. So the mean of Joey's sales is the same as the mean of Kamira's sales. And then the range of Joey's sales is greater than the range of Kamira's sales. So there's much more variability. So the typical number of shirts Joey sold each day was blank compared to the typical number of shirts Kamira sold. Their means were the same. The typical number that they sold was the same as. However, since the range of Joey's data was more than Kamira's, the number of shirts Joey sold varied more from day to day than the number of shirts Kamira sold. She kind of was pretty consistent on how many she sold. He had 2 bad days and 1 great day, and then there were some of those lower ones similar to hers. So that's all this is getting in and comparing information. So just recognize the measure of center, the median or the mean, compare how how much each day, or how much is regularly happening on each item. But the range is how much it varies by. So if you just keep that in mind, then you should be just fine finishing off this lesson. And after this lesson in your sixth grade book, there are only 2 lessons left. You're almost done.